So, good afternoon, everyone, and thank you for joining us. So, my name is Saoussen Chaabnia, and I'm a AI machine learning engineer and a solution engineer and consulting. And today I'm going to show you how to build a distributed AI agent system using Google latest AI stack. So, by the end of this presentation, hopefully you understand exactly how ADK, A2A, MCP, and Vertex AI Agent Engine works together to in real world system. All right, so let's begin. Let me introduce you to our AI Creative Studio, which is a distributed multi-agent system that automates social media campaign creation from start to finish. So from a single campaign prompt, this system gives you an entire campaign with market search, Instagram post, image prompts, quality review, and Notion project timeline. Using our specialized agent, as we see here, we have a brand strategist, we have a copywriter, a designer, a critique, and a project manager. These are fully distributed across Cloud Run, and they are coordinated by the creative director agent hosted in Agent Engine. Now that we have seen what's possible, let's understand how the technology makes this work. So let's start by ADK. ADK, or Agent Development Kit, is the framework to build our agent with minimal code. We also have ATA, which enables agent to communicate and discover each other dynamically. Then we have MCP, which connects agent to external tools like Notion databases, APIs, and other services. And finally, we have Agent Engine, which deploys everything into a managed infrastructure with autoscaling. So far we have build, communicate, integrate, and deploy. Each component in this Google AI stack solves a specific problem, and when they work together, you get what you just saw: a complete campaign in less than a minute from a single prompt. Now let's dive into each of this technology and see how they work together. So, Agent Development Kit is an open source framework for building, testing, and deploying AI agent. While optimized for Gemini and the Google ecosystem, ADK is model agnostic, meaning it works with any LLM, Gemini, Claude, ChatGPT, or other models. It's also deployment agnostic, meaning you can deploy anywhere where you have containerization. And it's built for compatibility with other frameworks, so it works well with LangChain, CrewAI, and other frameworks. So what does it include? This is not just a library you import. It's a complete development kit that includes agent classes and abstraction, built-in tools like Google search and code execution, plugin system for observability and logging, deployment utilities for production, and evaluation framework for testing agent performance, among other offers. Agent is the first class citizen in the agent development kit. There are four main components for an agent. We have the models, which are used to reason over goals, determine the plan, and generate a response. An agent can use multiple models. Second, we have tools. Tools are used to fetch data, perform action, or transaction by calling APIs or services. We also have orchestration, which is the mechanism for configuring the steps required to complete a task, and the logic for processing over these steps and assessing the required tools. It also permits you to maintain memory and state, including approach used to plan and any data provided or fetched, as well as the necessary tools. And finally, we have the runtime, which is simply the user to execute the system when invoked after receiving a query from an end user. So ADK makes it very simple to create and spin an agent in no time. Now, let me break down what an agent code actually looks like in ADK. Using one of our specialist agent we talked about, the brand strategist. We start by importing an LLM agent. This is the agent class for agent provided by ADK that uses the language model to reason and make decision. We create an instance of the LLM agent. This single line sets up your agent. We give it a name, so every agent have to have a name. This identifies it in logs, in traces, and when other agents calls it. And then we have to define a model. So by specifying which LLM to use. Here we are using Gemini 2.5 Flash. This is the model component, as we discussed earlier. This is the brain, and this is the brain of our agent, which permits it to reason and plan. And we have to define the tool. The tool definition invokes the tool component. Here we give the agent access to Google search. Tools let the agent fetch data and perform actions. The agent decides when to use them based on the task. All right, and last but not least, we have to define an instruction. This is crucial. The instruction is your agent system prompt, meaning it defines the role, the behavior guidelines, how it should use tools. This defines the agent expertise and personality. So that's it. In just 6 lines of code, you can spin up your first agent. So now for the orchestrator, we use the agent class instead of the LLM agent. This gives us more control for complex workflow. Just a second. Notice the tool parameter here contains other agents, like the strategist tool agent, the copyright tool, the designer tool, and etc. This is the agent tool pattern in ADK, which converts your agent into tools that can be used by other agents. We are wrapping remote agent as tools that the orchestrator can call. Behind the scenes, ADK handles the orchestration logic and meaning planning which agent to call and in what order to invoke them. It also handles memory and state, so it maintains conversation history and context. It also, for the runtime, executes the workflow when invoked. So you just write what your agent should do, and ADK handles the how, meaning how to make it happen reliably. So ADK builds individual agent, the brand strategy, the copywriter, the designer. But our AI Creative Studio have 5 specialist agents distributed across crowd runs. They need to coordinate. Without a standard, we would write custom networking code for each of connection to our specialized agent. We have to read code for endpoints, for authentication, for error handling, etc. We need what the REST API did for web services, a communication standard for AI agents. That's exactly what A2A does for our agent. So A2A, short for Agent to Agent Protocol, is an open standard for agent communication, like REST API but for AI agent. As at its core, A2A is an open protocol specification that standardizes how AI agents discover, communicate, and collaborate with each other. Think of it like creating a common language for a team of specialized agents. A2A lets agents talk to each other across networks, even if they're written in different languages or hosted in different places. As we can see in this example, we have an agent A that could be written in Python, run locally on your laptop, and we have an agent B that can be written in TypeScript, deployed to Cloud Run or Vertex AI Agent Engine. They communicate seamlessly via A2A over HTTPS. They don't need to know anything about each other implementation, just the protocol. So ATK is like the HTTP protocol for agent, just like how web servers and browsers agree on the HTTP to communicate, AA agent agree on A2A to communicate. So A2A also has 3 critical characteristics that makes it so powerful. At first, it is language agnostic, meaning that Python agent can talk to TypeScript agent. The protocol doesn't care what language you wrote your agent in. Second, it is framework agnostic, meaning ADK agent can talk to LangGraph agent, to Gruyere agent, or any other framework as long as they speak A to A. They can collaborate. Third, it is infrastructure agnostic. Your local agent can talk to your agent deployed to Cloud Run, to AWS Lambda, to Azure, anywhere. The agent just need to be reachable over HTTPS. This is what makes A2A a true open standard. It creates interoperability across the entire agent ecosystem. So, what does this mean in practice? It means that this enables us to build an agent once and reuse it anytime. Different teams can work in different framework, yet their agent can still collaborate seamlessly. Imagine agent works marketplace where you discover and connect to specialists on demand. That's what where true microservices for AI is enabled, and that's the architecture we use for our AI creative studio. So let's see how this works. First, the A to A, we have to specify an agent card. This is permits discovery via the agent card. This lives at the standard URL uh, at a slash point well known slash agent.json. So any agent can fetch it to discover what other agent can do, its skills, the parameters, and importantly, where it's served as an endpoint. The agent card is where agents advertise their capabilities. This enables dynamic discovery through skill advertising. Agents publish what they can do, so other agent can discover it at runtime. The second thing we have the A2A server, which is invoked, which is the actual endpoint that's invoked usually at handle message, where you can send commands. The orchestrator posts a JSON RCP message, invoke this message, like invoke the skills with these parameters, and the server execute the agent and return the result. So far, the agent card tells you what the agent can do, and the A2A server is where you send the commands to actually invoke it. So the third thing, we have the message format. So A2A uses a JSON RPC over HTTP. It's simple, language agnostic, and works everywhere you have HTTP. The orchestrator call an agent skill with parameter, just like calling a REST API endpoint. But instead of like returning static data, you get an AI-generated insight back. A2A supports multiple interaction pattern. Request response is what we use most. Ask a question, get an answer. But we also it also supports streaming for real-time updates and long-running patterns. So that's A2A, the protocol, the component, the interaction patterns. Now let me show you how we actually use this. In our AI Creative Studio, A2A enables our distributed architecture. So we have 5 specialized agents that need to work together. They are deployed to different servers on Cloud Run, but need to communicate seamlessly. To do this, we first define our agent normally. To do this, each specialized agent should expose an A2A server. How to do it? Second. Use an A2A and ADK. We just redefine an agent normally. We give it a name, tools, instructions, a model. This is a standard ADK. This is using a standard ADK code. Then, and this is the magic. When just one line of code using two A2A, given it the root agent, a host, and port and protocol. Um, um, this permits us to have to convert the ADK agent into an A2A compatible one. Using this utility function from ADK, it wraps your agent into an A2A server. It generates the agent card automatically. It sets up the JSON RCP endpoints and handles all the protocol details. So Since each of our specialist agent exposes an A2A server, the orchestrator needs to connect it to it as a client. So to call the A2A server, one of the clients in the client side, we create a remote A2A agent. You give it the URL to the agent card. ADK fetches it. It reads the compatibilities, its capabilities, and set up the connection. And as a result of this implementation, now our agent can be deployed independently. They can be replaced and updated without touching other agent, which enables our microservice architecture. So far, as we have seen, A2A handles agent communication, but agent also needs external tools to connect to databases, external services, APIs, or to connect to services like Notions. We could write custom code for each or standardize like we did here using A2A. That's where MCP comes in. MCP, short for Model Context Protocol, is an open protocol that standardizes how AI application connect to external data sources and tools. It creates a universal plugin layer between your AI model and the resources it needs to access. So instead of writing custom integration code for every tool you use, like Notion for project management, or Postgres database for data, Slack notification, for example, you use MCP servers, standardized proxies that expose tools to your AI in consistent format. This lets MCP server handles the how of tool integration, like authentication, data formatting, and error handling. So your agent only needs to know the what, which tool to call, and with what parameters. So let's understand how MCP work. MCP uses a simple client to server architecture. The MCP server connects to external resources like databases and APIs and exposes them as standardized tools. It handles authentication, data conversion, and error handling. The MCP client lives in your agent. It discovers available tools, sends requests, and passes results to the LLM. MCP servers run locally can run either locally as a sub process or remotely as a web service. Deploy whatever makes sense for your architecture. So let me show you how MCP in action with our project management agent. Our project management agents need to interact with Notion APIs. It needs to connect to pages in the project database, create task pages in the task database, link task to project, link task to project, and handle Notion complex property types and relationship. So Notion APIs is notoriously complex. Without MCP, this would be hundreds of lines of integration code. With MCP, using ADK, here's what we write. We just import the MCP utilities from ADK and configure the Notion MCP server. Notice we're using Notion official MCP server here. It's an NPM package maintained by Notion themselves. We tell ADK to spawn it with MPX and pass our API token. Then we create the MCP toolset. This connects to the MCP server. And finally, we add it as a tool into our agent. The advantage is that now our agent has full access to Notion API. It can retrieve database schema and discover property names dynamically. It can create pages in database and it can update existing pages with new data. So notice here we did like zero custom integration code, no authentication logic, no data format conversion. The Notion MCP servers handles everything. And here's the best part. When Notion updates its APIs or you connect to a new database, we don't touch our agent code. The MCP server automatically provides the update and handles different formats. All right, so now we have the complete development picture. We have seen ADK, which gives us the framework to build the agents. The A2A enables agent to communicate with each other, and the MCP connects agent to external tool and data. But there is one critical piece missing. Where do we actually deploy and run all of this in production? We need infrastructure, we need scaling, we need monitoring, we need logging, we need session management for multi conversation turns, etc. We could do this ourselves, like deploy this in Kubernetes, have a load, configure a load balancer, login pipelines, etc. But that's weeks of DevOps work. Or we could use a managed platform designed specifically for AI agent. That's where Vertex AI Agent comes in. The Vertex AI Agent is a Google Cloud fully managed platform specifically designed for deploying, running, and scaling AI agent in production. It it is essentially a specialized runtime environment that hosts your agent as a managed service. It handles all the infrastructure from server scaling and security, provides production features like login, monitoring, and versioning. It integrates natively with Google Cloud Services and manage agent state and context across conversation. Think of it like the serverless option for your AI agents. You deploy your agent code, and Google handles everything else. So, Agent Engine provides five production ready capability: managed runtime, auto provisioning resources, scales from 0 to 100 requests, handles deployment and rollbacks. Session management, this is where we store conversation history, manage agent memory across interaction, and support the long running workflow. We also have integrated observability, cloud with the cloud rigging, monitoring, and traces building. We can track everything from token usage to latency to request flow, and also have enterprise feature like VPC isolation, AAM access control, encryption, compliance certification, and it is also natively integrated with Google AI services like BigQuery, Cloud Storage, Secret Manager, and Vertex AI. This is why Agent Engine is perfect for our orchestrator. So, given going back to our example, in our AI Creative Studio, we use Agent Engine for the creative director orchestrator. The orchestrator have a special requirement. It requires complex state. It needs to track multi-agent workflow progress. It also needs to handle variable loads, sometimes one request, sometimes 100. And it's working with a long workflow, spinning sometimes 5 agents in sequence, which take like more than 45 seconds to run. And we also need enterprise readiness, like login, monitoring, security, to always have be up to date of what's going on inside our agent implementation. Here is how we architected our AI Creative Studio. We have five specialist agent: the brand strategist, the copywriter agent, the designer, the critique, and the project manager. All of these are deployed to Cloud Run. They are lightweight and stateless, so Cloud Run is perfect for our demo purposes. They communicate with the orchestrator via A2A over HTTPS. The creative director orchestrator is deployed to Agent Engine. It needs state management for the multi-agent workflow. It needs to handle variable load, and it needs enterprise observability. So, what makes Agent Engine perfect for this? This also demonstrate like how can leverage a hybrid architecture using the right platform for each component. So let me show you how to create the orchestrator that coordinates all of the 5 agents. First, we read the URLs of our deployed specialists from environment variables. These are set during deployment and point to our Cloud Run services. Second, we create remote A2A agent instances. Look at what happens here. So when we create a remote A2A agent, we give it the URL to the agent card. ADK makes an HTTP GET request to fetch the agent card, which permits it to discover what skills the agent has and sets up the A2A client connection. This is dynamic discovery. The orchestrator learn each agent what each agent can do at runtime. Third, we wrap each remote agent in an agent tool. converting the remote agent into a tool that the orchestrator agent LLM can call. Finally, we create the orchestrator agent. We give it we give it a name, specify the model, uh, the okay, and the instruction, and the five agent tools we just created. That's it. Now the orchestrator can now call all of the five specialized agents dynamically, discover what they can do at runtime, and take action based on its instruction for what to do with them and coordinate the workflow. Notes here, like we didn't we wrote like zero network code. We just like used the ADK integration with A2A and A2A to spin this app. So this is how ADK N2A handles all of this for us. And for deploying our orchestrator to Agent Engine, first we wrap our orchestrator in an app. So for transparency, usually we just pass the agent, but since we are using context compacting inside the code, this is critical for multi-agent workflow to avoid token limits. It needs to be wrapped into an app. Second, we call the reasoning agent create. This is the agent engine deployment API, which we pass it the app we just created. We and the requirement, like the Python package is needed, the display a name and a description, extra packages, which is our agent code directory, and the environment variable, which are the URLs of all the five specialized agents. Agent Engine um, takes our code, its packages, and it deploys it to a managed infrastructure and returns a resource name. And just like that, our orchestrator is now live. It's fully managed. It can be auto scaled, and it has logging and monitoring built in. And when we need to update, it, it may just like we by update our orchestrator by or improving it by changing the prompt or adding a sticks agent. We just run the script again, and instead of using create, use the update call, an update call, and our agent engine hands the building automatically. Okay, problem. Second, it's not. Okay, now that we have seen all of this, we can go to see the demo of our implementation. Just give me a second. Let's try to share it with you. Okay. Right. Very good. So, okay. I tried to set things up up front.
It's not visible. We see just wallpaper, your beautiful bird.
All right. Let
But
me.
visible.
Okay. Just a second. Let me share again. I'll stop sharing and try to share again. Screen. Okay. Do you see my?
Just your entire screen.
No, VS Code. Okay. No, VS Code. Now.
No.
No. All right. Sorry. Bear with me. But again. Now?
Yes.
Yes.
Now we can see your Visual Studio Code.
Okay, that's good.
Yes, Agent PI file.
Okay. So let's have quick work through the code. As we see here, we have every one of our agent in defined in its directory. We have the brand strategy, the copywriter, the critique, the designer, the project manager, and the creative director. Let's see as we have seen throughout. This is our brand strategy definition. We saw this before, it's the same, just give it an instruction. We define an agent, we give it a name, a model, instruction, and description, and we give it a tool. The instruction here defines the agent scope and how do you want it to behave. In our case, it is optimized research. And here, using two A2A, we take our agent and make it A2A compatible. As easy as that. It's the same for the other agent, and this is the code for our creative director. So in our creative director, as we've seen, the prompt is longer because it's specific to specifies multiple steps. You can return back to this later if you have some time. It's just a second. Go back here. As we have seen, we defined our agent URLs. We read them from the environment variables, and they are deployed to Cloud Run. We specified them as a remote A2A agent, so we can access them, and we have to specify the agent card, the agent card here, as we said before. And voila. We wrapped it in an agent tool here, like you see here. And then we just give the agent the list of the agent tool to our orchestrator agent, and now he's capable to use them use them when necessary, based on the planning and the reasoning it does using the LLM. Okay, so as I said before, I also tried to set up things. But before we start, before going into running the full system, let me show you how to test and visual agent using the A2A inspector. A2A inspector is a debugging tool that lets us communicate with agents using the A2A protocol. It's like Postman, like for AI agent. So here is the A2A inspector interface. Here I just spun it up. The interface is here. And what does it do? What does it need? You need here we see we can configure which agent to connect to. And specify which agent to connect to. We can send see the agent card, and we can send messages and see responses. So here I give it the URL of our brand strategies running in Cloud Run. This also needs some authentication, so I just use the token here. And when hitting connect, it will connect to the brand strategist in our Cloud Run and fetch the agent card. So let's explore what the agent card gives us. So our agent card, it shows the second. Okay. It shows a description of the agent. Here it says brand strategies for market research, trend analysis, and competitive insights. It shows the name of our agent, which is the brand strategist. It has protocol version, and the most important thing is the auto-generated skill card. It auto-generated the skills that is advertised to other agents, so they can know what this agent is capable of and decide to use it or not based on the requirements. So here we see the description of our brand strategies and its capabilities. It's also see what tools it uses and etc. So we just use Google search here, and given it prompt like search the market for eco-friendly water bottles, targeting health-conscious millennials. I need audience insight, competitor analysis, and trending topic. See, the prompt is a little bit specified, like you specify exactly like what you need and like specifying that you need competitor analysis and the trending topic. And we see that our agent executes the search, comes back with insights and gives us back the response. So that's it, simple. This is, I think, for development, this tool is very useful. So, and it helps you debug and see how things work. So that's why I wanted to introduce it to you. Now let's go back to um, our full orchestrator. Just give me a second. Mhm. Okay. Okay, so now here. Yeah, tell me.
No, it's okay. Now we can see your Google
Okay,
Cloud
you can see
platform.
yeah.
Perfect.
Good. So you see the Google Cloud, the Cloud
Yes.
Run interface? Good.
Yes.
So as we have seen, the orchestrator is great for testing individual agents in isolation, but the real power comes from when multiple agents work together. Now we are going to test our Creative Studio, which is deployed to see here Agent Engine. This is our Creative Studio in the background. And here we can see our specialized agents that are deployed to Cloud Run as separate services. So I did go ahead and let me see on this one because as I said before, I um, I did like this code like earlier this week, and then I didn't get back to it till today, and I encountered some problems I was fixing. Anyway, so as we have seen, our orchestrator is deployed to Agent Engine. Our specialists are deployed to Cloud Run, and now I'm using the Agent Engine playground to create a session and give it test it with a prompt. So the prompt for this test is to create a complete Instagram campaign for a product called Cloud Coffee Premium Subscription Service with ethically sourced beans. We specify our target audience and we specify our budget, and we also specify our timeline. And we to make sure that we run all the workflow, we can demand to have a market search to be very specific and ask for 3 Instagram posts with caption for visual concepts, quality review, and project timeline. So using this prompt, our agent would come up with, as we see here, with a plan. We start with a plan. It will say, I'm gonna start by using the brand strategist since we asked for market research. It will understand automatically that it needs to a copywriter for the Instagram captions. It will also understand that he needs a designer to create the visual concepts and to span up a critique to critique the output of the previous agent and review it. And it also understands that it needs to connect to the project manager agent to help it come up with a project a detailed timeline, task, and deliverables for the campaign. And then it starts like calling the specialized agent. So it hands off once it comes up with the plan. It starts executing it. Here we see that it hands off the work to the brand strategist, and we see because I specified in the prompt that it had to come up with to like to actually to like confirm that the agent that was called did give you a response and output if there is a problem, if it encountered a problem. So here we see that it confirms that the brand's password research is completed, the artifact that it received, and it decides to move on to the copywriter, passing also the information from the brand strategist, handing it back to the copywriter to work with the information, the coordinate between what the brand strategist did and what the copywriter need to output. Now, also see that the copywriter did its work. It's outputted a complete 3 Instagram posts with engaging caption, relevant hashtag, and clear call to action, all aligned with strategic insight. And now, as we can see, we continue the workflow using its plan. It will hand off this to the designer, then hand off this to the critique, and finally, it will hand off this to project manager. And after finishing, it will give you the whole like summary of everything, not a summary, like outputting a report of everything that was done. So at the end, we will get market research and strategy for our campaign, a detailed market research for our campaign using here like special formatting that was defined into the instruction prompt for every agent. So for the brand strategist, we asked it to come up with competitive analysis to for trending topics and key strategies, and it converts into its research into the output format. Does the same thing for the other agents. So this formatting is inclusive to the specialized agent, and it's rendered via what's the instruction in each of the specialized agent have. The same for all the other parts. You see the critical review, and if like there is a scoring there. If it passes, will directly get it to the project manager, and the project manager does come up with a timeline for each of the tasks with a timeline, a tasks, a project and tasks, and a timeline based on the output of all the other agents and the other agents. So yeah, that's it. One more thing. So project manager, as we specified before, uses MCP servers. So now we can like go to Notion to see. Okay, do you still like? Okay. Do you see the Notion interface?
Yes.
Okay. So I promise everything was working 2 days ago. Today, when just I'm trying, like I did just spin everything again, and I had a problem with the integration with Notion that I was trying to fix, and unfortunately didn't succeed. So in my Cloud Run logs, I can see that the orchestrator, when handing off the task of creating the project to the project manager, it actually comes up as we have seen with the plan, and it should like create it in Notion, but it didn't work. but I have like a demonstration from another prompt I used earlier this week. So we see here that earlier this week, when just prompting for another campaign for EcoFlow Smarter Water Bottle on social media campaign, it creates the project entry, and here it also creates the tasks. You see, the project entry gives the project name. It gives status. It gives the dates, the priorities, and it links it to. It creates a list of tasks, links it to the project, and also gives details about the tasks according to the Notion API database that it reads dynamically and figure out how to coordinate how to like coordinate its logic with the output needed. So here we see that the task can have a name, the status, the due date, priority, tags. All of this are dynamically generated using our project manager AI agent. And tell me if like we have more time, or so this is I finished the demo. Do you have time for other to discuss other points, or it's fine?
It depends of how many time do you need?
Um, did you pass the 40 minutes?
A few minutes.
No, did we pass the 40 minutes? So just okay. I'm gonna share this anyway.
Okay.
Okay. So I wanted to share some other interesting points related to how to spin. Do you see my what are you seeing right now?
Right now, your presentation,
A presentation. Okay, so the
orchestrator prompt architecture.
okay. Okay, let me see this my monitor so I can.
But now we see all your editor,
Yeah,
not presenter mode. Uh-huh.
this. All right. From the slide. No, doesn't work. Sorry. Where
That's
is
okay.
it?
Don't worry.
Because I put it down here. All right. Mhm. Do you see the slides?
Not slide. No.
No slide. Mm, okay. Anyway, we can pass anyway. I wanted just to share some tips about how do we prompt the orchestrator to make sure that it's like do the good job orchestrating the workflow, and some tips for deploying on Cloud Run using the 2A2A. There's some customization done there. But you can access this on my GitHub repo, and you have the details.
Okay, and feel free to share with me this link on your repo.
Okay,
I'll share in description
I'll share
under
it right
your
now.
video.
Okay, can I stop present sharing?
Yes, of course. Of course.
Okay, thank you. So thank
And
you.
biggest thanks for sharing your experience. And of course, in January, we will start, as always, series of events built with AI. I'll invite you for sure one more time. And we will have online event. We have more time. Now we have in-person event, hybrid, just one online session, and our agenda is strict.
Okay, so are there any questions? For a
So,
note, I shared the GitHub repo in
okay.
the chat.
Mhm. And guys, if you have any questions to our speaker, okay, Ilya. So, okay, I'm thinking how if speaker can hear your question. Let's try.
Hi, do you hear me?
Yeah.
Yeah, so, okay, so I'm first, yeah.
Yes.
Okay, so first of all, thank you for presentations. I like the topic. And the first question is about A2A protocol. So you just basically said it's an abstraction over gRPC protocol. And what's the reason, like what's the advantage of A2A protocol compared to gRPC? If we can just create simple web services with gRPC and run our agents and communicate with gRPC and not with A2A.
I'm not sure that I fully understand, but what I understood is okay. I'm just gonna respond to what I understood, and you can like correct me. So A2A is a protocol that is designed for AI agent. It actually uses JSON RPC over HTTP to for the communication. So if you implement it yourself, it will be like thousands of lines of code to make two agents, one build, say, on ADK and one build on line graph or to, to communicate to each other. So A2A comes in to provide a standardized way to do that. As I said before, like it's exactly the same thing as we did with HTTP. HTTP permits you to communicate between, to have like a standardized protocol communication between servers and your browser. So they just like have the same thing happens here with A2A. It's a standardized way for make agent to communicate. So as long as your agent supports A2A, and you can span in the A2A server and have an agent card, have an endpoint, it will do that automatically for you and permits agent to communicate, create an interoperability. So you can still use a JSON RPC, but the difference is using this component, using this like framework, this protocol. It will be easier to span things up because as you know, like a lot of work was done there to just make it so easy, so standardizable, and to make it usable, to make like lift like what you say. Lift like the complexity of building customized communication on your own for developers using other protocols.
Okay.
Did I respond to your question?
Yeah, so the reason in case of A2A, we don't have to handle the logic like in controllers, so to speak. Is it right?
Yeah, it's like a library. You use what provides like as we said we spin a server, we provide an agent card, like to use the steps and the logic that the philosophy that comes behind creating an A2A, and most of the things are gonna be done dynamically. One more point is, as we have seen in this demo, I didn't just use A2A protocol directly. I used the ADK implementation for A2A, and that permits us, like in one line of code, you have all this working for you, and you can use your agent now to connect to other agents, to connect to other services, to connect directly to your application. And I think this is an advantage. Uh, Otherwise, you would have to do all of the work for yourself, like the authentication. You have to do all handling. You have to make sure the handshakes are made. Everything. It's like very. I think very hard to do it without this kind of library.
Okay. Thank you. And the second
You're
question
welcome.
about your architecture and your with services. So you use basically director or orchestrator for it. And what would you do if one of the services doesn't respond? So, for example, we have downtime for one service or something like that.
So this is where the prompting comes in the orchestrator that I wanted to show. As we saw, the orchestrator was specifically in the prompt specified to have a plan. And specifically in the prompt, you give it the guidelines of how you expect it to behave. For my case, I told him like if everything works okay, just output that it's working okay, and we saw that it's executing. Like it's calling the agent come back with a response. it doesn't go to the next step until the response from that agent is correct. In my case, I also specified that if one of the agents didn't work, you stop. If the plan was to run all the workflow, you stop and you report back that to the user and or the developer. And so this is something like you customize depending on your work in your specified work. And this is the logic I implemented.
And are there some tools for agents like message brokers or async use to handle it and just not to send bad requests to the user if one of the services doesn't work?
Not yet, but again, you can do that either in your code using. There is tools like in case of ADK, you have callbacks. And these callbacks you can have like it permits you to inject logic into your agent. Um, Before like there's three type of callbacks. You can have a callback before the model execution or after the model execution. You can have a callback before the agent execution and after the agent execution, and you can use a callback before the tool execution and after the tool execution. So in this case, the callbacks, the most like common case for using callbacks is doing logging, doing like in your case you have like to do retries, to handle mistakes. You can use this to actually like handle this kind of cases. And what else? Um, I was gonna tell. What else? And you can also like do this without the callbacks. Handle this in your prompt. As you said, if you don't want it to be reported to the agent, you can specify a number of retries to the user. You can specify a number of retries, and in case of an error, you can ask the orchestrator to go back to the user with a custom message saying, "Sorry, I can't currently." Let's assess your request. Come back for like 5 minutes. The thing we usually do in software development, you can do that into your agent.
Have you tried to use not orchestration, but how does it, choreographic?
I didn't hear you. Sorry.
Have you tried to use choreographic instead of orchestration?
Choreographic instead of orchestration. Did you try it? Did you use it?
Coordination, it means?
Choreographic. So if you
Choreographic.
You don't have like the main component that delegates this task, but you have all services communicate with each other.
Like in a mesh. I didn't. In this use case, this is like for demo purposes. The main idea of this presentation was is how we can use our agent separately as a microservice and present one of the pattern we can use in agentic AI. The most like popular and pattern is orchestrator to other agents. You can do the mesh thing, but so in this implementation, I didn't try it.
Okay, sounds good.
So, Saoussen, one more time, big thanks for your time and Happy New Year. Okay, come here. Dennis, can you please power on light? Yes, come here with your question because I think speaker can hear you carefully. Yes, sorry for my microphone.
Well, thank you for the informative presentation. I have a question about the AD cost. So I work on medical AI and wanted to ask if there is any language model for radiology report generation.
Yeah, can you repeat, please?
In the AD cost, the agents, is there any language model for radiology report generation?
Not that I'm familiar with, but in your case, I think that you okay. You can use just one of the typical typical large language models out there, Gemini, and or even LLM, like an open source model, and you can
Gemma, trained medical.
yeah, and you can fine tune it to your. You can find use specifically. I think your case is about computer vision, so you can use a vision-related LLM and fine-tune it to your use case, and then you just use that as the model inside of your model call in the agent, and it will work perfectly.
Yeah, okay. Thank you so much.
Exactly, Gemma trained.
Yeah, you can use Gemma
or
because it's multimodal and yeah, it supports that.
easy
But
fine
in this case, you have to create your own
is best model
Yes.
for medical and fine tuning and privacy.
Yeah, I agree. I agree. Confirm.
So in this case, Gemma, best of the best. So guys, if someone have any questions, so we can give you applause.
Thank you. I hope you enjoyed the session, and I was very happy being among you today.
Biggest thanks for your impact. Biggest thanks for your support, our community. Thanks for your time, and
Thank
see
you.
you in our next
Okay.
session.
Until next time. Until next time.
See you next time. Yes. See you. Bye
See
bye.
you. Bye bye. Thank you, everyone.